Hello, good afternoon to you all. My name is Alokali and I will be taking up class 9 science. So today we will be discussing on a topic, force and laws of motion, that is chapter 9. In the previous chapter, you have already learned, the last two sessions, you have already learned the concept of motion, motion in a straight line, different types of motion, that is uniform motion and non-uniform motion. And also, you have also learned some of the quantities that are needed to describe the motion of the objects like speed, velocity, acceleration, distance, displacement, and so on. But you have not yet discovered why motion takes place or what causes motion or why the speed of an object changes with time, and also the nature of the causes of motion. So in this chapter, we are going to find out all the answers, all the reasons behind that, and we shall make an attempt to quench all such curiosities. That means this chapter is the continuation of the previous chapter, that is motion. And also in this chapter, we are going to study about different laws of motion. So this is the brief introduction of what we are going to study in this chapter. So in our everyday life, we observe that some efforts is required to put the stationary object into motion. So here, when I say stationary object, it means that the object which is at rest, which is not moving. So some efforts are required in order to put that stationary object into motion, or to stop the moving object. So when I say this, some of you might be confused, but what effort is needed in order to make something move or to stop something? So in order to make the concept clear, let me give you some examples. I'm going to give you so many examples so that you will be able to understand it clearly. The first example is, for example, this whiteboard is kept here. This whiteboard is kept here. That means this whiteboard is at rest. At rest means this whiteboard is not moving. So what do you think? Do you think that this whiteboard will move on its own? It will just move on its own? Then definitely the answer will be no. Why? Because any object that is at rest will never move on its own until and unless unless I come and push this whiteboard, or until and unless I come and pull this whiteboard will never move on its own. That means you have to put some effort, you have to put some force in order to move this whiteboard. That means some external forces is needed in order to put the stationary object to move. And again, second examples, for example, a toy car. That is, one toy car is here on the floor. If somebody comes and push it or pull it, only then the toy car will move. Otherwise, by just touching at the toy car, this toy car will not move on its own. That means for that also we need some force in order to let the toy car move from this place to another place. Again, another example is, imagine yourself that you are standing or you are sitting on a car or on a bus, and that bus is not moving. That means that bus is at rest. Imagine yourself that you are sitting or standing on that bus, and then suddenly if the bus starts moving, then what do you think, what will happen? Definitely your body will move backward. Yes, right. Definitely if suddenly the bus starts moving, your body will move backward. And I'm sure most of you have experienced this also. So have you ever imagined, or have you ever thought that why these things happen, or why your body moves backward when the bus or when the car suddenly starts? So all these answers we are going to find out in this chapter. That is because of the force exerted by the engine, our body is pulled backward. And again, another example is, for example, take a soft take a soft rubber ball in your hand, or try to put the soft rubber ball in between the palms of your hand and try to squeeze that rubber ball, or try to press or try to push the rubber ball with both your hands. What will happen is the shape of that rubber ball will change, or the shape of that rubber ball will get distorted, because you are applying some force with your hand, only then the shape of the rubber ball change, right? That means even force can even change the shape and size of an object. Again, another example I will give you. For example, a ball on a football ground. Only when somebody come and hit that football, only then the ball will move. Otherwise, the ball will never move on its own. For that, you have to apply a force on your feet, and then if you hit that ball, only then the ball will move on. So from all these examples, we understand that there is something which is common for all these things and is responsible for all the changes that is taking place. And that is nothing but we call it as force. So let us go back again to all the examples that I have given you. You have applied force, and then applying force, because of force, you could move this whiteboard from one place to another. By applying a force, you could able to, the toy car moves forward, and because of force, your body is pushed backward when the car suddenly starts, or when the car suddenly stops. And again, even because of force, it can change the shape and size of an object, of a rubber ball that I have given you the example. And not only that, by hitting a ball, because of the force, you hit the ball and then the ball starts moving. So basically, force is nothing but, force can be defined as push, so force can be defined as push, pull, or hit, which tries to change the state of rest. I repeat again, force is defined as push, pull, or hit that tries to change the state of an object, rest. So the concept of force is push, pull, or hit. So it is because of force that motion is taking place. Some external forces is needed in order for a stationary object to move. So this is all about force. I hope all of you are clear with the concept force. Now let us go into the next topic, that is balanced and unbalanced force. So here, what is balanced and unbalanced force? Let me explain to you one by one. Here, so what is balanced force? Balanced force is nothing but equal and opposite force is known as balanced force. So the name itself, it says balanced means what? Both sides have to be equal. That means the right hand side have to be equal to left hand side. So when I say equal means, again, equal means equal in magnitude, and opposite means equal in magnitude and opposite in direction. That is, this is the definition of balanced force. Balanced force, it means equal in magnitude and opposite in direction. Again, here the new terms comes here. What is magnitude? So magnitude is nothing but it is the numerical value that defines the measure of a quantity. So I repeat, magnitude is nothing but it is the numerical value that defines the measure of a quantity. So let me give you again another example. For example, one table is here. So a wooden block is placed on this table, say, and on both the end of this wooden block, a string or a thread is tied on this side and in this direction also. So a wooden block is placed on a table, and on both the end, a string or a thread is tied on both the sides. And as we all know, the unit of force is Newton. So if we apply 1 Newton, we apply a force of 1 Newton in this direction, say, and again the same force, that is 1 Newton here in the opposite direction, and if you try to pull the string on both the end, then what will happen? Since the magnitude is same, that means magnitude means, as I have said, numerical value. So the magnitude will be here 1, and also on this side the magnitude will be 1. Since the magnitude, the force is same, that is on both sides 1 Newton and 1 Newton, this wooden blocks will not move. It will just remain as it is. That is, it will be at rest. It will not move. That means this is called equal in magnitude. That is 1 Newton and 1 Newton. And since they are, one is on the right hand side and the other is on the left hand side, that means they are opposite in direction. So this is called balanced force, that is equal and opposite force. And one important thing is, again here, balanced force do not cause any change in motion. That means balanced force do not cause any change in motion. When I say this, that means on both sides the magnitude is same. So even if you try to pull the string on both the end, it will just stay as it is. It will not move. It will not move in any of the direction. That means it will not cause any change in motion. Now, what is unbalanced force? Say, let us consider a situation. The same examples we will take. Say let us consider a situation of two opposite forces of different magnitude. If we apply a force of 1 Newton in this direction, and on the opposite direction, if we apply a force of, say, 3 Newton, and try to pull the string on both the end, what will happen? Definitely the block will start moving towards this direction, the greater force, where there is a greater force. That means here, if the force are both the force are not equal, right? On one side it is 1 Newton, and on the other side that is 3 Newton. So if the force are not equal, then there comes an unbalanced force. So unbalanced force is nothing but unequal force. We call it as unbalanced force. Unbalanced force can be defined as unequal force. That means one side, the magnitude is different in both the directions. So unbalanced, this means the magnitude of force in one direction is either greater or lesser than that of the other direction. And we have seen that in balanced force, it causes the motion. Whereas in case of unbalanced force, it causes change in motion. That means if we try to pull, the magnitude is different, one side is greater or lesser than the other side. So if we try to pull, definitely the blocks tries to move in the direction where there is a greater force. That means it causes the motion. So we can say that balanced force is equal and opposite force, and unbalanced force is unequal force. So I hope you are clear with this balanced force and unbalanced force. So now let us talk about different laws of motion. So now let us talk about different laws of motion. When I say laws of motion, LAWS, that means S is plural. That means there is more than one laws. So we will be discussing what are the different types of law. So in order to describe the motion, Newton has given 3 types of laws. That is first law of motion, second law of motion, and then third law of motion. So all these laws of motion are known as Newton law of motion. So we will be discussing one by one. The first is Newton first. So what is Newton's first law of motion? Newton's first law of motion states that a body at rest tends to be at rest, and a body in uniform motion tends to be in uniform motion until and unless an external force is applied on it. Let me write this. A body at rest So for Newton's first law of motion states that a body at rest tends to be at rest, and a body in uniform motion tends to be in uniform motion until and unless some external forces are applied on it. That means Newton's first law of motion talks only about uniform motion. So let us divide this definition into 2 parts. The first part is a body at rest tends to be at rest. What do you mean by that? At rest. That means which is not moving. The same example, I have given you this board, this whiteboard or whatever. Suppose I have kept my pen on the table. The pen will not move on its own until and unless somebody comes, apply some force, and then you pick it up or you pull it or you push it, only then it will start moving. So that means anything that is at rest, any object that is at rest will not move until and unless some external forces are applied on it. And similarly, the second portion is a body in uniform motion tends to be in uniform motion. So that means moving with a constant velocity. The object will move with a constant velocity. So when I say constant velocity, that means we are talking about frictionless surface. Where there is no friction, the object will keep on moving with a constant velocity until and unless some external force is applied on it to stop the object. So here, this is known as Newton's first law of motion. So we have learned that a body at rest, the tendency of a body to remain at rest and to be in the uniform motion. So this tendency is nothing but we call it as inertia. This tendency to be at rest and the body to be in the uniform motion, we call it as an inertia. And that is why the first law of motion is also known as law of inertia. And inertia is nothing but the body at rest will remain at rest, and the body in the uniform motion will remain in uniform motion. And one important thing is inertia of an object, inertia of a body is directly proportional to mass. This part is again very important. So inertia is directly proportional to mass. It is not inversely proportional, but it is directly proportional. Sometimes in one word, multiple choice answers, this might come. Inertia is directly proportional or inversely proportional to mass. So I want you all to know this, that inertia is directly proportional to mass. So when I say directly proportional to mass, then what do you mean by directly proportional to mass? That means if the object has more mass, then you need to apply more force in order to move that object from one place to another. So let me give you again one example. For example, you have two boxes. One box is empty, and the other box is filled with, say, full of books or whatever. So what do you think? Which one will you be able to push it easily? Empty box or the box that is filled with full of books? So it will be easier to push the empty box than that of the box which is filled with books. That means the force that is just enough to push or to move that empty box will produce a negligible change. The force that is just enough to push that empty box will produce a negligible change in the motion of box that is full of books. So here, if we compare this two, that is empty box and the box that is full of books, then we can see that the box which is filled with books have more inertia than that of the other box that is empty. So that means more heavy object or massive objects offers larger inertia, and if the object is heavy, if the mass of an object is more, then the inertia will also be more, and also so the resistance to move the object will also increase. So we can see that from here, we can see that if the mass of an object is more, then you need to apply more force in order to move that very object from one place to another place. So we can see that inertia, so that is called inertia, is directly proportional to mass. And basically, there are again three categories of inertia. So the inertia of rest, inertia of motion, and inertia of direction. So let us see them one by one. The first one is inertia of rest. So what is inertia of rest? Inertia of rest is nothing but a tendency of a body to remain at rest. The tendency of a body to remain at rest until some external unbalanced force is acted on it. So the definition of inertia is a tendency of a body to remain at rest until some external unbalanced force acted on it. The simple example is, say, on a carpet. Dust particles that is on a carpet will just remain in the carpet that is at rest. It will not move until somebody comes and hit that carpet, or until somebody comes and shake that carpet. The dust particles will remain in that carpet that is at rest. So this is called inertia of rest. And the second one is inertia of motion. So what is inertia of motion? A tendency of a body to continue to be in a motion until some external unbalanced force is acted on it. I will not write this definition on the board. Let's not consume time. So, for example, you are sitting or standing on a moving bus. Now I am talking about a moving bus. Okay, the bus is not at rest, but the bus is moving. So you are sitting or standing on a moving bus, and suddenly, if the bus stops, what will happen? Your body will move forward. your body will move forward. This is because the lower portion of your body, which is in direct contact with the bus, stops, but then the upper portion keeps is in the state of motion. This is because of the inertia of motion. Inertia of motion, your body tends to move forward even if the bus stops. So this is because of inertia of motion. And the third one is inertia of direction. So what is inertia of direction? Inertia of direction is a tendency of a body to oppose. So here the term comes again, oppose. To oppose any change in the direction of motion. Oppose it is the tendency of an object, tendency of a body to oppose any change in the direction of motion. For example, again, when the car takes a sharp turn, what will happen? Your body will push on one side of the car. So this can be explained on the basis of inertia of direction. At first, the car was moving in a straight direction, and suddenly, if the car takes a sharp turn, then your body is pushed towards the other direction. This is because your body is already chasing the direction, and when the car applies an unbalanced force to change the direction of the motion, then it is because of the inertia of the body, that is inertia of the direction, your body tends to be pushed to other side of the direction. So this is called inertia of direction. Inertia of rest, it is the tendency of a body to remain in its state of rest until some external unbalanced force is acted on it. And inertia of motion is nothing but it is the tendency of an object to to continue to be in a state of motion until some external unbalanced force is applied on it. And the inertia of direction is the tendency of a body to oppose any change in the direction of motion. So this is all about Newton's first law of motion. Now the second is, let us discuss what is Newton's second law of motion. So Newton's second law of motion is often seen in the action of our daily life. So let us recount some of the observations of our daily life. So let me give you some examples. So the first example is, while playing a table tennis game, if the tennis ball hits you, then it will not make any difference. That means you will not get hurt. Why? Because the mass of the tennis ball is light. But then if a fast-moving cricket ball comes and hits you, then I'm sure you will get hurt. So why? Because the mass of an object, that is mass of the ball, is very heavy. And not only that, but if you just throw a stone on the wall, then the wall may not get damaged. But if somebody comes and fire a bullet on the wall, then definitely the wall will make a hole, and then definitely the wall will get damaged. That means the small bullet applies more force than that of a bigger stone. And not only that, but a truck that is parked, that will not make any difference. That means that will not require any attention, but a car or a truck which is moving, even with a very low speed, if it hits somebody, then it may even kill a person. From all these observations suggests that the impact produced by all this object depends on mass and velocity. That is mass and velocity. So when I say mass, means how heavy or light the object is, and velocity means how fast or how speed or how slow the object is moving. So we need to put more force in order to make the object move faster. If we hit a ball with more force, then the ball will go faster. But if the ball is heavy, that means we need to apply more force. So there must be a quantity. So there must be a quantity that combines both mass and velocity, and Newton has termed it as momentum. So momentum is nothing but the product of mass and velocity, and momentum can be denoted by the letter small p, and since the definition is momentum is the product of mass and velocity, so mathematically we can write this momentum as small p is equal to mass into velocity. And the SI unit of momentum is kilogram meter per second. This is the SI unit of kilogram per second. So from here we'll stop. We'll continue with this second law of motion is not yet finished. We'll continue the second law of motion in the next class. Thank you.